Welcome to Tech with Kaushik. This is part 3 of our complete practice question series for the AZ-104 Microsoft Azure Administrator exam. Test your knowledge with exam-focused questions covering key Azure administration concepts. Choose your answer before the timer ends, then review the correct answer, clear explanation, and practical exam tip. Let us begin part 3. The next item is question number 87. This question focuses on Azure Bastion. Scenario: your organization has two virtual networks, VNet Core and VNet Spoke, which are connected via VNet peering. You need to deploy Azure Bastion to VNet Core to securely manage virtual machines in both virtual networks. The deployment must meet the following technical requirements: support host scaling to accommodate concurrent sessions from a large administration team, support file upload and download capabilities, minimize the number of IP addresses allocated to the Azure Bastion subnet. How should you configure the Azure Bastion deployment? Review each blank and choose the most appropriate option. Review Statement 1, Azure Bastion subnet size, the blank. The options for this statement are /24, /26, /28, or /29. Review Statement 2, Public IP configuration, the blank. The options for this statement are basic SKU with a dynamic allocation, basic SKU with a static allocation, or standard SKU with a static allocation. The answer to the first statement is /26. The standard SKU requires a subnet size of at least /26 to accommodate host scaling. The answer to the second statement is standard SKU with a static allocation. The Bastion standard SKU requires a standard public IP with a static allocation method. Remember this distinction for the exam. Always use a /26 subnet for Azure Bastion subnet to ensure future scalability. The basic SKU cannot scale beyond 2 instances, and the standard SKU demands a /26 subnet to scale effectively. Now consider question number 89. Review the situation. Your organization routes all internet-bound traffic from Azure Virtual Networks back to the on-premises data center using forced tunneling over a site-to-site VPN gateway. You have a virtual machine, VMDB, in a virtual network that needs to write database backups securely to an Azure storage account named SPACkups. You must ensure that traffic from VMDB to SPACkups does not traverse the on-premises VPN connection, but instead travels directly and securely over the Microsoft backbone network using a dedicated private IP address in the virtual network. Which of the following should you configure to meet this requirement? Available choices. Option A, private endpoints. Option B, Azure AD Application Proxy. Option C, a Network Security Group, NSG, rule. Option D, Azure Peering Service. The required response is option A, private endpoints. This is correct because a private endpoint assigns a dedicated private IP address from the virtual network's address space to an Azure PaaS service, like Azure Storage. Because the destination IP is within the VNet, traffic from VMDB to the storage account remains entirely within the virtual network and the Microsoft backbone, bypassing the 0.0.0.0/0 default route that forces internet-bound traffic over the VPN gateway. The alternatives can be eliminated because B, Azure AD Application Proxy is used to publish internal web applications to the internet securely, not to route traffic to Azure Storage. C, an NSG can allow or block traffic, but it cannot alter the routing behavior of forced tunneling. D, Azure Peering Service enhances connectivity to Microsoft Cloud services from an ISP, but it does not resolve VNet routing for private access to a storage account. A useful examination rule is this. When forced tunneling is enabled, 0.0.0.0/0 points to on-prem, traffic to Azure PaaS public endpoints will drop or hairpin. You must use private endpoints, allocates a private IP, or service endpoints, adds a specific route, to bypass the forced tunnel. Let us focus on question number 90. This scenario establishes the key requirement. Your organization routes all internet-bound traffic from Azure Virtual Networks back to the on-premises data center using forced tunneling over a site-to-site VPN gateway. You have a virtual machine, VMweb, in a virtual network that needs to read assets from an Azure storage account named SCAssets. You want to ensure that traffic from the virtual network to SCAssets is routed directly over the Microsoft backbone network rather than being forced out the VPN gateway. You do not want to consume private IP addresses from the subnet for this connection. Which of the following should you configure on the subnet to override the default forced tunneling route for storage traffic? Focus on the distinction between these options. Now examine choice A, Azure Firewall. Now examine choice B, Service Endpoints. Now examine choice C, a Network Security Group, NSG. Now examine choice D, Azure AD Application Proxy. The correct answer is option B, Service Endpoints. The key reason is when a service endpoint is enabled on a subnet for a service like Microsoft Storage, Azure automatically adds a specific system route to the subnet's effective route table. This route directs traffic for the storage service directly over the Azure Backbone network. Because this route is more specific than the 0.0.0.0/0 forced tunneling route, the storage traffic bypasses the VPN gateway. Furthermore, unlike private endpoints, service endpoints do not consume a private IP address from the subnet. The other choices do not satisfy the requirement because A, Azure Firewall is a network security appliance and does not inherently solve the forced tunneling override for pass without UDRs. C, a Network Security Group, NSG, controls access, allow/deny, but does not dictate routing paths. D, Azure AD Application Proxy publishes on-premises apps to the cloud. Keep this examination point in mind. Service endpoints inject a direct system route to the Azure PaaS service, taking precedence over default routes, like forced tunneling, without requiring a private IP address on the subnet. Question number 94. Requires careful analysis. This question moves us into Azure Site Recovery. Identify the decisive requirement in this scenario. Your organization is planning disaster recovery for 50 on-premises virtual machines hosted in VMware vSphere. You will replicate the machines to Azure by using the modernized Azure Site Recovery architecture. You have created a Recovery Services Vault in the target Azure subscription. What should you do next to prepare the source VMware environment for replication? Eliminate any option that fails a requirement. Consider option A, configure an extended network. Consider option B, deploy the Azure Site Recovery Replication appliance from the downloaded OVF template to vSphere. Consider option C, create a recovery plan in the Azure portal. Consider option D, perform a test failover. The best answer is option B, deploy the Azure Site Recovery Replication appliance from the downloaded OVF template to vSphere. The requirement is satisfied because the modernized VMware to Azure architecture uses an on-premises replication appliance for discovery, coordination, and replication. After Vault preparation, deploy and register the appliance from the OVF template in the source vSphere environment. Now consider why the remaining options are unsuitable. A. Extended networking is not a prerequisite for replication. C. Recovery plans are created after machines are protected. D. A test failover is performed only after replication is configured and healthy. Exam tip. For modernized VMware disaster recovery, deploy and register the replication appliance before enabling replication for source virtual machines. Proceed to question number 95. You maintain a Bicep module designed to deploy standard Azure storage accounts. The deployment pipeline runs at the subscription level. You need to modify the Bicep template so that it specifically deploys the storage account into an existing resource group named RG Storage, rather than the default target of the parent deployment. Which property should you configure on the module definition in the Bicep file to ensure the resources are placed in RG Storage? Review the options. Choice A, SKU. Choice B, kind. Choice C, location. Choice D, scope. The appropriate choice is option D, scope. The reasoning is as follows. By default, when you execute a Bicep deployment at a specific scope, like a subscription, all resources and modules within the file inherit that scope. If you need a specific module to deploy its resources into a different resource group, you must set the scope property on the module declaration, passing the target resource group using the resource group RG_storage function. The incorrect choices fail for the following reasons. A. The SKU property determines the pricing/performance tier, for example, standard_LRS, not the deployment destination. B. The kind property specifies the type of storage account, for example, storage v2, blob storage, not the resource group. C. The location property specifies the Azure region, for example, ESTIS, where the resource physically resides, not the logical resource group container. In Bicep, you use the scope property on modules or extension resources to deploy them to a resource group, subscription, or management group that is different from the target scope of the parent deployment. Question number 97. Highlights an important distinction. We are moving to virtual machines. Focus on the following situation. You have an Azure subscription containing two resource groups, RGApp, location, East US, RGDB, location, West US. You have pre-provisioned three proximity placement groups, PPG1, resides in RGApp, location, East US PPG2, resides in RGDB, location, West US PPG3, resides in RGApp, location, West US. You are preparing to deploy a new virtual machine scale set named VMSS Web to the West US region. The scale set will be placed in the RGApp resource group. To minimize network latency, which proximity placement group or groups can you assign to VMSS Web during deployment? The relevant choices are as follows. Option A, PPG1 only. Option B, PPG2 and PPG3 only. Option C, PPG3 only. Option D, PPG1, PPG2, and PPG3. In this case, select option B, PPG2 and PPG3 only. Here is the technical justification. A proximity placement group, PPG, is an Azure logical construct used to ensure Azure compute resources are physically located close to each other in the same data center to minimize network latency. A PPG is bound to a specific Azure region when it is created. VMSS Web is being deployed to the West US region. Therefore, it can only be associated with proximity placement groups that are also located in the West US region, PPG2 and PPG3. The location of the resource group, RGApp, does not restrict the placement of the compute resources, as long as the resources region matches the PPG's region. The remaining options are incorrect because A, PPG1 is located in East US. You cannot assign a West US VMSS to an East US PPG. C, while PPG3 is in West US, PPG2 is also in West US. Both are valid options, so limiting it to PPG3 only is incorrect. D, PPG1 is invalid because it is in East US. The key takeaway is proximity placement groups are strictly region-bound. When associating a VM or VMSS with a PPG, both resources must reside in the exact same Azure region, regardless of which resource group they belong to. Question number 98. Consider this scenario. Your organization routes all internet-bound traffic from Azure Virtual Networks back to the on-premises data center using forced tunneling over a site-to-site VPN gateway. You have a virtual machine, VMweb, in a virtual network that needs to read assets from an Azure storage account named SCAssets. You want to ensure that traffic from the virtual network to SCAssets is routed directly over the Microsoft Backbone network rather than being forced out the VPN gateway. You want to accomplish this without deploying additional dedicated network interfaces. Which of the following should you configure on the subnet to override the default forced tunneling route for storage traffic? The options are: Option A, Azure Peering Service. Option B, a Network Security Group, NSG. Option C, Service Endpoints. Option D, Azure Application Gateway. The appropriate choice is option C, Service Endpoints. Enabling a service endpoint for Azure storage on a subnet injects specific routes into the subnet's effective route table, pointing directly to the Azure PaaS service over the Microsoft Backbone. This automatically overrides the less specific 0.0.0.0/0 forced tunneling route. Because service endpoints do not consume a private IP address in your VNet, unlike private endpoints, which use dedicated network interfaces, they meet the requirement of not deploying additional dedicated network interfaces. A. Azure Peering Service provides reliable routing from an ISP to Microsoft, but does not configure internal VNet routing overrides. B. An NSG can allow or deny traffic, but it cannot override routing rules to bypass forced tunneling. D. Azure Application Gateway is a Layer 7 web traffic load balancer and cannot be used to route storage traffic or override VNet routing. Remember this distinction for the exam. If a requirement asks to bypass forced tunneling to reach past services without using a private IP or creating new network interfaces, the correct answer is always service endpoints. Now consider question number 99. Next, we enter the topic of VNet peering. Review the situation. Your company operates two applications deployed in Azure. App A is hosted in a virtual network named VNet East, East US region. App B is hosted in a virtual network named VNet West, West US region. The applications must frequently exchange large datasets. You need to ensure that the communication between the two virtual networks traverses the Microsoft Global Backbone securely, providing low latency and high bandwidth. What should you configure to connect the two virtual networks? Choice A. Virtual network peering. Choice B. A route table with user-defined routes. Choice C. An express route circuit. Choice D. A private endpoint. The required response is option A. Virtual network peering. This is correct because virtual network peering, specifically global VNet peering in this scenario, as the VNets are in different regions, allows you to seamlessly connect two Azure virtual networks. Once peered, the virtual networks appear as one for connectivity purposes. Traffic between virtual machines and peered virtual networks is routed directly through the Microsoft Backbone infrastructure, ensuring high bandwidth and low latency securely without traversing the public internet. The alternatives can be eliminated because B. User-defined routes alone cannot establish connectivity between two isolated virtual networks without a peering connection or a gateway. C. ExpressRoute is used to connect an on-premises data center to Azure over a private connection, not specifically to connect two Azure VNets together, though possible, it's highly inefficient and costly compared to peering. D. A private endpoint is used to connect to a specific Azure PaaS resource, like storage or SQL, not to connect two virtual networks together. A useful examination rule is this. Global VNet peering is the simplest, most secure, and most performant way to connect virtual networks in different Azure regions over the Microsoft Backbone. Review question number 100. Carefully. Let us first review the situation. You manage an Azure subscription with the following virtual networks: VNet A, 172.16.0.0/16, VNet B, 172.16.1.0/24, VNet C, 10.0.0.0/16, VNet D, 192.168.1.0/24. You need to establish network connectivity between VNet A and the other virtual networks using virtual network peering. Based on the IP address space allocations, which virtual networks can be successfully peered directly with VNet A? Choose from the following options. Option A is VNet B only. Option B is VNet C and VNet D only. Option C is VNet B and VNet C only. Option D is VNet B, VNet C, and VNet D. The correct answer is option B, VNet C and VNet D only. The key reason is to establish virtual network peering. The IP address spaces of the two virtual networks must not overlap. VNet A uses the 172.16.0.0/16 address space, which covers IP addresses from 172.16.0.0 to 172.16.255.255. VNet B uses 172.16.1.0/24, which falls entirely within VNet A's address space. This creates an overlapping address space, meaning VNet A and VNet B cannot be peered. VNet C, 10.0.0.0/16, does not overlap with VNet A. VNet D, 192.168.1.0/24, does not overlap with VNet A. Therefore, only VNet C and VNet D can be peered with VNet A. The other choices do not satisfy the requirement because A, VNet B explicitly overlaps with VNet A, making peering impossible. C, VNet B overlaps and cannot be peered. D, VNet B overlaps and cannot be peered. Keep this examination point in mind. Always check for IP address space overlaps before attempting to configure VNet peering or VPN gateways. Azure strictly prohibits peering VNets with overlapping CIDR blocks. Let us work through question number 102. Consider the following scenario. You are an administrator for an Azure environment linked to a Microsoft Entra tenant. The tenant contains the following security groups: SEC Group 1, assigned a Microsoft Entra IDP2 license, SEC Group 2, no assigned licenses. The tenant contains the following cloud-only users: Admin User 1, member of SEC Group 1, no direct licenses. Admin User 2, not a member of any group, has a direct Microsoft 365 E5 license. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, you can delete SEC Group 1 without removing its assigned license first. The second statement is, you can delete Admin User 1. The third statement is, you can delete Admin User 2 without removing their direct license first. The answer to statement 1 is yes. Deleting the cloud-only group removes its license assignment and reclaims the licenses. The answer to statement 2 is yes. Group membership and inherited licensing do not prevent deletion of a cloud-only user. The answer to statement 3 is yes. The user can be deleted and the directly assigned license is reclaimed. Exam tip. Delete cloud-only identities in Microsoft Entra ID, manage synchronized identities from their authoritative on-premises directory. Question number 103. Scenario. You manage an Azure environment containing two virtual networks, Core VNet and App VNet. Core VNet and App VNet are peered with each other. You deploy the following resources: DBVM, a virtual machine connected to a subnet in Core VNet. API App, an Azure App Service web app using the Premium V3 pricing tier. It is regional VNet integration enabled and is integrated with a dedicated subnet in App VNet. Backend App, an Azure App Service web app deployed in an app service environment, ASE, V3, isolated tier, connected to a subnet in Core VNet. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. API App can communicate securely with DBVM over the Microsoft backbone via VNet peering. Statement 2. An NSG applied to the App VNet integration subnet controls inbound internet traffic connecting to API App. Statement 3. Backend App can communicate with resources in App VNet via the established VNet peering. For the first statement, choose yes. Regional VNet integration allows outbound traffic to reach resources in peered virtual networks. For the second statement, choose no. VNet integration is used exclusively for outbound traffic from the web app. Inbound traffic bypasses this integration subnet unless a private endpoint is also configured. For the third statement, choose yes. Because Backend App is in an ASE deployed directly inside Core VNet, it behaves like a standard VNet resource and can communicate across the peering to App VNet. Standard regional VNet integration only affects outbound traffic from your app service. To restrict inbound traffic at the network level, you must use private endpoints or access restrictions. The next item is question number 104. The focus now shifts to container instances. You are configuring an Azure Container Instances (ACI) deployment named AppGroup1. You plan to deploy two containers in the same container group with the following settings: SKU, standard OS type, Windows memory, gigabytes 4 number of CPU cores. 2. The option to add a second container to the container group is unavailable. Which parameter must you modify to deploy both containers in the same container group? The options are: Option A, SKU. Option B, OS type. Option C, number of CPU cores. Option D. Memory, gigabytes. The best answer is option B. OS type. The requirement is satisfied because Azure Container Instances supports multiple containers in one container group only for Linux containers. Changing the OS type from Windows to Linux enables the multi-container configuration. Now consider why the remaining options are unsuitable. A. The standard SKU does not cause the multi-container limitation. C. The configured CPU count does not determine whether a second container can be added. D. The configured memory does not determine whether a second container can be added. The key takeaway is ACI multi-container groups are supported for Linux containers. Windows container groups support a single container. Proceed to question number 105. Consider this scenario. You have an Azure subscription containing an Azure Container Registry, ACR, named AcroProd 2026. To support a legacy deployment script, you enable the admin user setting on AcroProd 2026. You need to instruct your developers on how to authenticate using the admin user account. Which username should they use to sign in? Available choices. Choice A, AcroProd 2026. Choice B, root. Choice C, admin. Choice D, AcroProd 2026 admin. In this case, select option A, AcroProd 2026. The reasoning is as follows. When you enable the admin user for an Azure Container Registry, the username generated for authentication is exactly the name of the registry itself. In this scenario, it is AcroProd 2026. The incorrect choices fail for the following reasons. B. Root is a Linux concept, not the ACR admin username. C. Admin is not the username, the feature is called admin user, but the username is the registry name. D. ACR does not append admin or any other suffix to the registry name for the admin username. Remember this distinction for the exam. The ACR admin user provides quick, simplified access for testing or basic deployments. The username is always the name of the registry, and 2 passwords are automatically generated so you can rotate them independently. We will now analyze question number 106. Review the scenario carefully. You have an Azure subscription containing a recovery services vault named Backup Vault East deployed in the East US region. The subscription contains the following virtual machines: Server 1, Windows Server 2022, deployed in East US Server 2, Ubuntu Server 22.04, deployed in West US Server 3, Windows Server 2022, deployed in West US Server 4, Red Hat Enterprise Linux, deployed in East US Server 5, Windows 11, deployed in Central US. You need to configure Azure Backup using Backup Vault East. Which virtual machines can you back up to this vault? Now examine the possible answers. Choice A, Server 1 and Server 4 only. Choice B, Server 1 only. Choice C, Server 1, Server 2, Server 3, Server 4, and Server 5. Choice D, Server 2, Server 3, and Server 5 only. The required response is option A, Server 1 and Server 4 only. Here is the technical justification. A recovery services vault can only back up resources that are deployed in the same Azure region as the vault itself. Operating system, Windows or Linux, does not restrict backup capabilities, but the region is a strict boundary. Since Backup Vault East is in East US, only Server 1 and Server 4, which are also in East US, can be backed up to it. The remaining options are incorrect because B, Server 4 is also in East US and runs a supported OS, Linux, so it can also be backed up. C, Server 2, Server 3, and Server 5 are in different regions, West US and Central US, and cannot be backed up to an East US vault. D, this selection targets only the virtual machines that are explicitly in the wrong regions. A useful examination rule is this. To back up Azure virtual machines, the recovery services vault and the virtual machines must reside in the exact same Azure region. You cannot back up a VM across regions to a single vault. Let us examine question number 107. Begin by examining the scenario. You manage an Azure subscription with the following resources: Web Server VM, a virtual machine in the Central U.S. region. Datastore SA, an Azure storage account in the East U.S. region. Your organization's security policy requires that all communication between Web Server VM and Datastore SA happens exclusively over the Microsoft Backbone network and never traverses the public internet. You need to configure Datastore SA to meet this requirement. What should you configure? Compare the following options. Option A is a private endpoint. Option B is a shared access signature, SAS. Option C is storage account firewalls configured with a public IP whitelist. Option D is advanced threat protection. The appropriate choice is option A. A private endpoint. A private endpoint assigns a private IP address from your virtual network to the storage account. This ensures that all traffic between the VM and the storage account travels entirely over the Microsoft Backbone network via the VNet, and global peering, if applicable, bypassing the public internet completely. B. A SAS token provides authorized access control but does not alter the network routing or prevent traffic from traversing the internet. C. A public IP whitelist still requires traffic to hit the storage account's public endpoint, meaning it can traverse the internet. D. Advanced threat protection monitors for anomalies and threats, it does not change network routing paths. Keep this examination point in mind. To completely remove exposure to the public internet for Azure PaaS services, like storage or SQL, deploy an Azure private endpoint. Service endpoints also use the backbone but keep the PaaS service's public endpoint active unless firewalled. Proceed to question number 108. The focus now shifts to Azure Files Identity. Your organization uses an on-premises Active Directory Domain Services (ADDS) environment. The ADDS domain synchronizes to your Microsoft Entra tenant by using Microsoft Entra Connect. You deploy an Azure storage account named Corp Files and create an Azure Files share named Finance Share. You configure the storage account to use ADDS for identity-based authentication. Default share level permissions are set to none. You assign the following Azure RBAC roles on Finance Share: Alice, an ADDS synchronized user storage file data SMB share reader; Bob, a cloud-only Microsoft Entra user storage file data SMB share contributor; Finance Group, an ADDS synchronized group storage file data SMB share contributor; Charlie is an ADDS synchronized user who is a member of Finance Group. The NTFS access control lists on Finance Share grant Alice read permission and Finance Group modify permission. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1, Alice can read files in Finance Share. Review Statement 2, Bob can modify files in Finance Share. Review Statement 3, Charlie can modify files in Finance Share. Statement 1. The answer is yes. Alice is synchronized from ADDS and has both the share level reader role and NTFS read permission. Statement 2. The answer is no. Bob is cloud only and cannot use ADDS Kerberos authentication for this share. Statement 3. The answer is yes. Charlie is synchronized from ADDS and receives share level and NTFS modify access through Finance Group. Exam tip. For Azure files with ADDS, effective SMB access requires both a share level role and file or folder permissions. The next item is question number 109. Scenario. You have an Azure storage account named Archive Data. You need to grant an IT staff member named Alex the ability to view and regenerate the storage account access keys for Archive Data. Solution: you assign the reader and data access role to Alex on the storage account. Does this meet the goal? Review the options. Option A. Yes. Option B. No. The best answer is option B, no. This is correct because the reader and data access role allows a user to read the storage account properties and read data within the storage account. It does not grant permission to list or regenerate the storage account access keys. The alternatives can be eliminated because A. Assigning this role fails the requirement. To list and regenerate keys, the user requires a role like storage account key operator service role or contributor. The reader and data access role enables viewing data via the portal, but managing access keys requires explicitly higher privileges like storage account key operator service role. Let us examine question number 110. Treat this as an easy question. Begin by examining the scenario. You have an Azure storage account named Archive Data. You need to grant an IT staff member named Alex the ability to view and regenerate the storage account access keys for archive data. Solution: you assign the storage account encryption scope contributor role to Alex. Does this meet the goal? Review each available choice. Choice A, yes. Choice B, no. The correct answer is option B, no. The key reason is the storage account encryption scope contributor role is used exclusively to manage encryption scopes for blob data. It does not grant the Microsoft storage accounts list keys action or regenerate key permissions required to manage the account access keys. The other choices do not satisfy the requirement because A, assigning this role fails the requirement. To list and regenerate keys, the user requires a role like storage account key operator service role or contributor. The key takeaway is storage account RBAC is highly granular. Only roles with key operator or generic contributor capabilities can list or regenerate the master storage account keys. We will now analyze question number 112. Review the scenario carefully. You manage an Azure environment containing two subscriptions, ProdSub and DevSub. The subscriptions are associated with different Microsoft Entra tenants. You have the following virtual networks: VNet A, East US, ProdSub, VNet B, East US, ProdSub, VNet C, West Europe, ProdSub, VNet D, East US, DevSub, VNet E, Central US, DevSub. All virtual network address spaces are non-overlapping, and you have the required permissions in both tenants. You need to establish connectivity between VNet A and the other virtual networks by using virtual network peering. Which virtual networks can you peer with VNet A? Compare the following options. Choice A, VNet B only. Choice B, VNet B and VNet C only. Choice C, VNet B and VNet D only. Choice D, VNet B, VNet C, VNet D, and VNet E. Choice E, VNet B, VNet C, and VNet D only. In this case, select option D, VNet B, VNet C, VNet D, and VNet E. The requirement is satisfied because VNet peering can connect non-overlapping virtual networks across regions, subscriptions, and Microsoft Entra tenants. Because the address spaces do not overlap and the required permissions are available, VNet A can be peered with every listed VNet. Now consider why the remaining options are unsuitable. A. Peering is not limited to the same subscription and region. B. Cross-subscription and cross-tenant peering is supported. C. Global VNet peering supports different regions. E. VNet E is also eligible despite being in another region, subscription, and tenant. Remember this distinction for the exam. VNet peering can cross regions, subscriptions, and tenants, but address spaces must not overlap and both sides require authorization. Review question number 113. Carefully. Let us first review the situation. You deploy an Azure virtual network named Core VNet in the West US region. The virtual network contains a subnet named App Subnet. You also deploy an Azure virtual machine attached to App Subnet using a network interface named App NIC. You create a custom route table named Routing Table 1. You need to apply Routing Table 1 to control traffic flow. To which resources can you associate this route table? Choose from the following options. Option A is Core VNet only. Option B is App Subnet only. Option C is App NIC only. Option D is App Subnet and App NIC. Option E is Core VNet, App Subnet, and App NIC. The required response is option B, App Subnet only. The reasoning is as follows. In Azure, user-defined routes, UDRs, defined in a route table can only be associated at the subnet level. Once associated, the routing rules apply to all resources, like NICs, within that subnet. The incorrect choices fail for the following reasons. A. Route tables cannot be applied at the VNet level, they must be attached to specific subnets. C. Unlike network security groups, NSGS, route tables cannot be attached directly to individual network interfaces, NICs. D. Route tables cannot be applied to NICs. E. Route tables are strictly applied to subnets, not VNets or NICs. A useful examination rule is this. While network security groups, NSGS, can be applied to both subnets and individual NICs, route tables are exclusively associated with subnets. Now consider question number 114. The difficulty level here is medium. Review the situation. You are an administrator for a Microsoft Entra tenant. You need user-created Microsoft 365 group names to use the following format: company - group name - department. You will configure a group naming policy in the Microsoft Entra Admin Center. Select the 3 actions that you should perform and place them in the correct order. The available items are: Entry 1, add a prefix of type string with the value company - add a suffix of type attribute with the value department, and then select Save. Entry 2, select Microsoft Entra ID groups all groups. Entry 3, upload a custom blocked words file. Entry 4, select naming policy group naming policy. The completed sequence is: the first item is select Microsoft Entra ID groups all groups. The second item is select naming policy group naming policy. The third item is add a prefix of type string with the value company - add a suffix of type attribute with the value department, and then select Save. Here is the technical justification. The naming policy is configured from the groups area. A static string prefix places company - before the user-entered group name, and the department attribute configured as a suffix places the department after it. Keep this examination point in mind. A Microsoft 365 group naming policy uses the pattern prefix, group name, suffix. Attributes can be used as prefixes or suffixes. Let us work through question number 115. Consider the following scenario. You are configuring an Azure Virtual Network named VNet Prod with an IP version 4 address space of 10.50.0.0/16. You create a subnet named Subnet Web with an address range of 10.50.1.0/26. You plan to deploy Azure virtual machines into Subnet Web. What is the maximum number of IP addresses available for you to assign to virtual machines in this subnet? Now examine the possible answers. Choice A, 59. Choice B, 64. Choice C, 62. Choice D, 251. The best answer is option A, 59. A /26 subnet contains 64 addresses. Azure reserves the first 4 addresses and the last address in every subnet, leaving 64-5 is equal to 59 addresses available for resources. The remaining options are incorrect because B, 64 is the total address count before Azure reservations. C, 62 assumes only the network and broadcast addresses are unavailable. D, 251 is the usable count for a /24 Azure subnet. Exam tip. Azure reserves 5 addresses in each subnet. 410.50.1.0/26, they are 10.50.1.0 through 10.50.1.3 and 10.50.1.63. Let us work through question number 116. Let us first review the situation. You have an Azure subscription and a local workstation with the Azure CLI and Docker installed. You have just built a local container image named WebAppImage v1. You need to provision a new Azure Container Registry and then upload your local image to that registry. Select the correct CLI commands to fulfill each requirement. Complete each statement by selecting the appropriate value. The first statement reads, to provision a new Azure Container Registry, run the blank. Select from 1. AZ-ACR build, AZ-ACR create, or AZ container create. The second statement reads, to upload WebApp image v1 from your local machine to the registry, authenticate and then run the blank. Select from 2. AZ-ACR build, AZ container create, or Docker push. For statement 1, select AZ-ACR create. This Azure CLI command provisions a new ACR instance. For statement 2, select Docker push. Since the image is already built locally, Docker push uploads it to the container registry. Use AZ-ACR build when you want Azure Container Registry to build the image directly from source code in the cloud. Use Docker push when you have already built the image locally. Question number 118. We are moving to public IP addresses. Consider this scenario. You have an Azure subscription containing the following resources: VM data, an Azure Virtual Machine VNet Core, a virtual network NIC data, a network interface attached to VM data LB external, a standard public Azure load balancer ASG web, an application security group. You provision a new standard SKU public IP address named PIP main. You need to associate PIP main with a resource to provide inbound internet connectivity. Which 2 resources from your environment can be directly associated with PIP main? Select 2. More than one answer may be correct. Choice A, VM data. Choice B, VNet Core. Choice C, NIC data. Choice D, LB external. Choice E, ASG web. The choices that satisfy the requirement are option C, NIC data, and option D, LB external. This is correct because a standard public IP can be assigned to an IP configuration on a network interface or to the front-end IP configuration of a standard public load balancer. A. The public IP is associated with the VM network interface, not directly with the VM resource. B. A public IP is not attached directly to a virtual network. E. An application security group groups NICs for NSG rules and cannot hold a public IP. The key takeaway is public IP resources attached to front-end or IP configurations, such as ANIC or public load balancer front-end. The next item is question number 119. Review the situation. You have an Azure subscription containing the following resources: Web App Prod, Azure App Service Web App, in the East US region in Resource Group RG Web. Key Vault East, Azure Key Vault, in the East US region in Resource Group RG Vaults. Key Vault West, Azure Key Vault, in the West US region in Resource Group RG Vaults. Key Vault EU, Azure Key Vault, in the North Europe region in Resource Group RG Vaults. You want Web App Prod to securely retrieve database connection strings stored as secrets. You must implement the most secure identity mechanism that eliminates managing credentials and code. Select the appropriate options to fulfill the requirements. Choose the correct entry for every drop-down field. For the first statement, to authenticate the web app, you should configure the blank for Web App Prod. The available choices are 1. User account, managed identity, service principal, or shared access signature. For the second statement, Web App Prod can be granted access to retrieve secrets from the blank. The available choices are 2. Key Vault East only, Key Vault East and Key Vault West only, Key Vault East, Key Vault West, and Key Vault EU, or none of the vaults. Statement 1 should be completed with managed identity. Managed identities are the recommended best practice for Azure resources to authenticate securely to Key Vault without storing credentials. Statement 2 should be completed with Key Vault East, Key Vault West, and Key Vault EU. Managed identities are a tenant-level construct and can be granted permissions to resources across different resource groups and Azure regions. Remember this distinction for the exam. Azure Managed Identities eliminate the need for developers to manage credentials. They can cross regional and resource group boundaries, as long as the resource resides within the same Microsoft Entra tenant. Question number 120. Scenario. You have an Azure subscription containing a storage account named CorpData. By default, the storage account is accessible from all networks. You need to restrict access so that CorpData is only accessible from specific Azure virtual networks and your corporate office's public IP address. You must minimize administrative effort. What should you do first for CorpData? Option A. Change the public network access setting to enabled from selected virtual networks and IP addresses. Option B. Create a private endpoint for the storage account. Option C. Modify the access control (IAM) role assignments for the storage account. Option D. Change the routing preference to Internet routing. The appropriate choice is Option A. Change the public network access setting to enabled from selected virtual networks and IP addresses. The key reason is to restrict access to specific IP ranges, like a corporate office, and specific VNets. You must first change the storage account's network settings to enabled from selected virtual networks and IP addresses, often referred to as enabling the storage firewall. Once this is selected, you can add the specific IP address ranges and VNet rules. The alternatives can be eliminated because B, while a private endpoint provides private VNet access, it does not facilitate access from an external public IP address without complex routing, for example, VPN/ExpressRoute. Modifying the public network access settings directly supports adding public IP ranges with the least administrative effort. C. Access control, IAM, dictates who can access the data or manage the resource, but it does not restrict access based on network origin. D. Routing preference determines how traffic reaches Azure, Microsoft Global Network versus ISP network, but does not restrict access by IP or VNet. A useful examination rule is this. To use Azure storage firewalls and restrict access to specific public IP addresses and subnets, you must flip the public network access toggle from enabled from all networks to enabled from selected virtual networks and IP addresses. Proceed to question number 121. This question moves us into user-defined routes. You have an Azure subscription and you are configuring a custom route table named UDR Web. You are adding a new route that will direct all traffic destined for 10.1.0.0/16 to a third-party firewall deployed in your virtual network. You know the exact private IP address of the firewall appliance. When configuring this route, which next hop type must you select to allow specifying the IP address? Available choices. Choice A. Virtual appliance. Choice B. Virtual network. Choice C. Internet. Choice D. Virtual network gateway. In this case, select Option A. Virtual appliance. The requirement is satisfied because when creating a user-defined route, UDR, selecting the virtual appliance next hop type is the only option that allows, and requires, you to specify the explicit next hop IP address. This is used to route traffic through NVAs, network virtual appliances, such as third-party firewalls. The other choices do not satisfy the requirement because B. Virtual network routes traffic directly within the VNet and does not accept a custom IP address. C. Internet routes traffic out to the Internet and does not accept a custom IP address. D. Virtual network gateway routes traffic to an attached Azure VPN or ExpressRoute gateway and does not accept a custom IP address. Keep this examination point in mind. Only the virtual appliance next hop type allows you to define a specific IP address in an Azure route table. If you need to route traffic to an NVA, you must use this hop type. Now consider question number 122. Consider this scenario. You manage an Azure availability set named AZ-DB that contains 3 virtual machines, DB Node 1, DB Node 2, and DB Node 3. You need to resize DB Node 1 to a newly released VM size to increase its performance. However, when you attempt to change the size, the intended size is grayed out and unavailable. What must you do first to resolve this issue and successfully resize the virtual machine? The options are: Choice A. Stop, deallocate all virtual machines in the availability set. Choice B. Stop, deallocate only DB Node 1. Choice C. Remove DB Node 1 from the availability set. Choice D. Convert AZ-DB into an availability zone. The correct answer is option A. Stop, deallocate all virtual machines in the availability set. The reasoning is as follows. Virtual machines in an availability set are pinned to a specific hardware cluster. If a new VM size is not supported by the hardware cluster currently hosting the availability set, you cannot resize a single VM independently. You must stop, deallocate all virtual machines in the availability set. This releases the allocation from the current cluster. Once all are deallocated, you can resize the desired VM, which may cause the entire availability set to be allocated to a new cluster that supports the size. Now consider why the remaining options are unsuitable. B. Deallocating only DB node 1 is insufficient because the VM is still constrained by the cluster hosting the other running virtual machines in the availability set. C. Once a VM is created, you cannot remove it from or add it to an availability set without deleting and recreating the VM. D. You cannot directly convert an availability set into an availability zone. They are fundamentally different architectural deployments. Exam tip. If a VM size is unavailable for a VM in an availability set, you must deallocate all virtual machines in that set before resizing, as the entire set must be moved to a different underlying hardware cluster. Proceed to question number 123. Next, we enter the topic of container registry. Scenario. You manage an Azure container registry named Acromages that contains a Linux container image named WorkerApp v1. You attempt to deploy an Azure container instance using the Azure portal by selecting the WorkerApp v1 image directly from the registry. The deployment fails with an authentication error indicating the registry credentials could not be retrieved. You need to ensure that you can successfully deploy the container instance using the Azure portal interface. Solution: you set the admin user property to enable for Acromages. Does this meet the goal? Review the options. Option A. Yes. Option B. No. The appropriate choice is option A. Yes. Here is the technical justification. When deploying an Azure container instance directly from an Azure container registry using the Azure portal UI without configuring a managed identity, the portal relies on the ACR admin user credentials to authenticate and pull the image. Enabling the admin user resolves this authentication error for simple portal deployments. The incorrect choices fail for the following reasons. B. The solution successfully meets the requirement. While using a managed identity is a better security practice for production, enabling the admin user is a direct and valid fix for this specific portal deployment failure. The ACR admin user provides quick, simplified access to the registry. It is often required when rapidly deploying container instances from the portal or using simple Docker login commands without Entra ID service principals. Question number 125. You have an Azure storage account named Archive Data. You need to grant an IT staff member named Alex the ability to view and regenerate the storage account access keys for Archive Data. Solution: you assign the storage account key operator service role to Alex on the storage account. Does this meet the goal? Option A. Yes. Option B. No. The required response is option A. Yes. The storage account key operator service role specifically grants the permission to list and regenerate the access keys for a storage account, Microsoft storage accounts /list key /action and regenerate key. It is a built-in role designed exactly for this administrative purpose. The remaining options are incorrect because B. The solution is completely correct, so no is incorrect. The key takeaway is to follow the principle of least privilege, use the storage account key operator service role rather than contributor if a user only needs to manage storage account keys. Apply precise reasoning to question number 126. Pay close attention to every stated constraint. You are preparing an Azure Resource Manager, ARM, template to deploy a virtual machine scale set consisting of Windows Server 2022 virtual machines. You have a PowerShell script that downloads and installs a proprietary monitoring agent. You need to ensure that this script executes automatically on every virtual machine in the scale set immediately after the VM is deployed. Which feature should you include in your ARM template? Evaluate each option against the stated requirement. Next, Option A, Azure Custom Script Extension. Next, Option B, Microsoft Entra Application Proxy. Next, Option C, Azure Automation Update Management. Next, Option D, Azure AutoManage. The best answer is Option A, Azure Custom Script Extension. This is correct because the Azure Custom Script Extension downloads and executes scripts on Azure virtual machines. It is explicitly designed for post-deployment configuration, software installation, or any other configuration tasks. It can be easily embedded within an ARM template or bicep file to run on all nodes of a virtual machine scale set upon creation. B. Microsoft Entra Application Proxy is used to provide secure remote access to on-premises web applications, not for executing scripts on virtual machines. C. Update Management is used to manage OS updates and patches, not for running arbitrary post-deployment initialization scripts. D. Azure AutoManage automatically configures virtual machines with best practice Azure services, like backup and log analytics, but is not a script execution engine. Remember this distinction for the exam. Whenever a scenario asks for a way to run a configuration script or install software immediately upon VM or VMSS deployment via templates, the custom script extension is the primary tool. Review question number 127. Carefully. Consider the following scenario. Your organization has an Azure subscription containing two peered virtual networks named Hub VNet and Spoke VNet. You deploy a third-party firewall appliance as a network virtual appliance, NVA, named Firewall NVA in Hub VNet. IP forwarding is enabled on the NVA, and the peering permits forwarded traffic. You need all traffic originating from Spoke VNet and destined for Hub VNet to be routed through Firewall NVA for inspection. What must you configure to enforce this traffic path? Review each available choice. Option A is a route table containing custom user-defined routes, UDRs. Option B is a service endpoint on the subnet in Spoke VNet. Option C is a local network gateway in Hub VNet. Option D is Azure Bastion in Hub VNet. In this case, select Option A. A route table containing custom user-defined routes, UDRs. The key reason is a route table associated with the Spoke VNet subnet can override the peering system route and specify the Firewall NVA private IP as the virtual appliance next hop. IP forwarding and forwarded traffic peering are already enabled. The alternatives can be eliminated because B, a service endpoint secures access to supported PaaS services and does not steer VNet traffic through an NVA. C, a local network gateway represents an on-premises network for VPN configuration. D, Azure Bastion provides administrative connectivity to virtual machines and does not control transit routing. A useful examination rule is this. To force traffic through an NVA, use a UDR with next hop type virtual appliance and ensure IP forwarding and forwarded traffic are enabled. The next item is question number 128. This one is marked hard, eliminate the options systematically. Review the situation. You manage an Azure environment with the following management hierarchy. Tenant root group MG Corp subalpha MG Retail subbeta subalpha contains RG data, which contains a storage account named Storage99. Subbeta contains RG Compute, which contains a virtual machine named VMweb. You assign the following Azure RBAC roles: Alice, contributor at the MG Retail scope Bob, storage account contributor at the Storage99 resource scope Charlie, user access administrator at the tenant root group scope. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1, Alice can change the VM size of VMweb. Review Statement 2, Bob can create a new storage account inside RG Data. Review Statement 3, Charlie can assign Alice the owner role for RG Compute. Statement 1 should be marked yes. Contributor at MG Retail is inherited by Subbeta, RG Compute, and VMweb. Statement 2 should be marked no. His role is assigned only on Storage99 and does not grant resource group level creation rights. Statement 3 should be marked yes. User Access Administrator inherited from the tenant root permits role assignments at RG Compute. Keep this examination point in mind. Azure RBAC inheritance flows downward. A role assigned to one resource does not grant permissions over its parent resource group. You have completed Part 3 of the AZ-104 Microsoft Azure Administrator Exam Practice Series. Keep building your Azure administration skills by opening the complete playlist and continuing with the remaining parts in sequence. If this session helped your preparation, like the video, subscribe to Tech with Kaushik, and enable notifications for more certification exam practice content. Share your score, doubts, or feedback in the comments. I would be happy to hear how your preparation is going. Thank you for learning with Tech with Kaushik. Keep practicing, and I will see you in the next part.